So, we know very little about our universe. We know a little about some planets, or what we think we know about some planets, and we know what NASA and their artistic renditions say about certain planets. And we know what data has been collected on certain planets. But the fact of the matter is, we really don't know anything. Most of it is speculation. Most of it is observation using tools that we designed to gather certain results to further bolster our opinions and theories on the formulation of planets and what they are. So, I recently watched this video, probably a couple of days ago, talking about the sun not being a gas or a compressed gas or actually on fire, or a plasma for that matter. That it's a seriously dense and densely compressed or immensely compressed state of liquid. Um, could be very possible. I mean, the theories that do wrap around that, the sun itself being a ball of plasma, kind of fall flat when you think about certain theories or aspects of relativity. Then you lose some of it when you have to think of it as a gas or a gaseous state or in a liquid state. It makes more sense. But the misconception of the sun being a fireball may be because we're thinking of the sun in the wrong manner. There were certain scientists in our past that contended the universe was electric, that scarring on the surface of Mars does show an electrical storm or a superstorm could have basically obliterated the surface or maybe caused enough static discharge to kill the planet in such a way. Maybe. It's still speculation and still theory, but no proof or solid fact in any of that that really is beyond visual proof or circumstantial evidence that points to it being possible. Now, some of that does occur in our times that we can see things that it does look this way, and there's tons of evidence that point to that direction, but that doesn't necessarily mean that's the case because you can get confused in today's times pretty quickly on what really is and what really isn't. So, the universe, in a nutshell, is pretty much a collection of planetary bodies. We are theorizing that are a certain size and a certain distance away from our host planet or our home planet we call Earth. Now, what we know about physics and what we know about the physical world is changing all the time. And what we understand about physics and what we understand about planetary bodies and other kinds of bodies that are collected through the universe are changing every day. What we understand about those planetary bodies and what we understand about those, the existence of those planetary bodies throughout space is also changing and evolving with each generation. Everyone gets a little bit smarter or a little bit dumber, but the point is the only way to learn is to fail. The only way to understand failure is to learn. And the only way to move past failure is to succeed beyond your failure or learn from your mistakes. So, the best way to understand what the universe could be and what it is that you're constantly learning, that you never know the whole truth, that once you do know, then you'll have a fact in your hands. That doing the same experiment different ways can often lead to similar results, which could prove your theory, but it also means that you have a very effective way of testing, not a very effective way of gathering results. Which is also, a lot of the problem in today's mainstream science. They've narrowed it down to one way of doing things, and that's the scientific method, which does work. It's a very proven method, but there are certain tactics and methodologies that are at every scientist's employ that aren't always 100% accurate and don't account for certain things like mass or density. Not in every aspect, and even if it does account for density and mass, it's not going to account for actual density or mass because there's no way of us actually knowing that based on a visual observation of any given point. So looking to that in the future, we'll know that maybe we can discuss what things really are once we've actually achieved true evidence to point to that fact. Now, speaking on certain things like Saturn's hexagonal, there we go, hexagonal north or south pole, and we can assume it's probably the same on the other side. But the North Pole having a hexagon around it may just mean energetic capability does show itself through geometry. And geometric shapes do oftenly lead to numerology, which leads you to the understanding of the lazy eight or the pyramidal shape that occurs when numbers are arranged in a certain form. Gives you an arrangement of that to understand geometry and numerology come from the same discipline of science. That alchemy can show you a little more, but some of the ways viewing planets through different spectrums of light can give you an idea as to their composition. Now, that's predicated on the idea that you have an accurate definition of what colors certain elements present themselves in a vacuum or supposed vacuum that space is, or a supposed understanding that each chemical, given different environments, can compose itself as one color or another all the time. That's also an assumption, not an actual reality. Through the testing methods, we have understood that if we're going to point a camera at some object here on the surface of Earth and say that the chemicals read back as that color, you're also understanding that the colors that present themselves as different materials are composed in a surface-like state on this planet, which has a serene environment for us to thrive in. That way, on a different planet, something else could be presented as just that object, and maybe we can assume it's water, but it may be something else entirely. Even based off of spectrometry, it's not an exact science. There are some things that do produce the same colors that aren't the same materials. Now, given that density and mass and pressure all act differently upon different things, is something to note, especially when you're doing any sort of spectrometry study, looking at different planets through a telescope with a mass spectrometer attached to it. Now, the correct assumption about planetary bodies and stars has yet to be understood. What I think is going on is that we are continually developing new technology. We're continually developing new ways of understanding physics and understanding what things actually are. So, learning about your different planetary bodies or stars, for that matter, by their presentation in our own environment, what we can see them as through our own atmosphere, we know that the sun is very bright. That looking at it, it's a very bright star, and it's the only one we have that's this close that keeps life thriving on this planet through the action of plants using it for photosynthesis and us using it for, everything else we use it for our body's metabolism and our skin's health and vitality is all based on the sun's rays and the emissions of said sun rays. But knowing that everyone can learn differently and at different rates about the same thing is one thing we must come to terms with, that science is never exact. It's only exact on a theory, and it's only exacted upon that theory by the person who propounds that, or contends that theory, and the proponents of said theory. So, understanding that physics is something that's always changing, that we can have an influence on physics, that we can continually learn about planets and stars based on our observations is a good thing. Now, that we don't know everything is also good, because it means we have room to learn and room to grow. Now, one thing I did want to mention that a lot of people aren't talking about these days because, well, the person that talked about it the most has recently passed away. My condolences to anyone who's related to the Hawking family. Stephen Hawking passed away very recently, and I want to offer my condolences for his family and anyone who was around him at that time. I'm very sorry for your loss, and we lost a great mind. And now, his theories on black holes and proven science on black holes is kind of questionable to some degree, because I think he was putting his own assumption into some of the theories and basing all of his science off a predisposed or presupposed disposition based on those theories. So understanding what black holes are requires a black hole to be present for us to study it. Now, the problem with black holes is they're elusive. You can't see them. Not in space, not readily, because they do bend light around them and they're virtually impossible to see. So, one of the best indicators we have, I witnessed from NASA's JPL, from a certain woman who's also a planetary scientist who studied it at the NASA's JPL, looked at planets zooming around a certain point in the a distant area of the space that we call our home, near the center of our own galaxy, saying that these planets were looping around a black hole at the center. Now, we know they're looping around something at the center, but we don't know that it's a black hole. We can assume that. That's an assumption. It's probably more likely what Michio Kaku was talking about being a white hole, or some of the theories floating around it being a white hole. Now, that's definitely possible because it does have a lot of matter coming out of it. Black holes were actually built upon the assumption they are vacuums or drains in space, so to speak, where things come in but never come out. But it's quite possible the theory may be true that black holes are indeed the opposite end of a wormhole, that there's a star on the other end of it. That's another theory that was tossed around, that white holes were also the other end of a black hole, maybe. But we all know that the realm of black holes and white holes are still mostly theory, and that any observation of black holes is still speculative. So what really may exist that we can contend as a black hole may be a tear in space-time, or may be a way to loop space-time back upon itself, thus creating a never-ending loop of time, creating an eternal void, so to speak. Now, what can happen when that occurs is that the loop can occur and everything can happen within that loop and it seems to never end because things repeat themselves. Similar to the way reincarnation is understood, that when one passes away here, they go somewhere else for a time and they're reincarnate back on this earth as another person, typically with the same personality, same soul, but a different genetic makeup, making them slightly different than they were in a previous life. Reincarnation, in a nutshell. But that is also itself a loop of existence, or a cycle of existence, the cycle of life. You're born, you live for a time, then you die, and you repeat that process through reincarnation, or reincarnated theory, basically, that you can come back as the same being as another human, or come back as a different thing, like a cow or a tree or a bird or a butterfly. Not really factual and no proof to that whatsoever, but still speculative. Now, the fact that that exists in speculation and is called mystical or esoteric, or folklore or mysticism in a sense, I think that you look at it like that because it's kind of woo-woo theory, right? But the same thing can be said about planetary theory and black holes. It's woo-woo because you've never seen one. You just have this assumption that that's what it is. That because it's a point to which everything around it rotates, that must mean it's a very massive object to attract all that around it. Well, the point is, if a black hole existed there, it would need to be so large that it would probably inhabit much more space than is observed to inhabit around the center of our galaxy, and would require a lot more mass than it actually does or is observed to have, or that it would gobble up everything in the nearest range. So those things have not occurred, which means it's probably not a black hole at the center of our galaxy. It's probably not a black hole. So theories are meant to be debunked or meant to be studied more, proven or disproved. That's what theories are meant to do. They're meant to be educated guesses, and then to form a hypothesis around. When you do apply the scientific method and you discover you're wrong, then you're to correct said hypothesis to the facts, and not contend or continuously contend this false theory or false narrative of black holes existing in that regard. So nothing short of wormholes was talked about or theorized by Einstein and certain other scientists in history, but we do have the ability to discern fact from fiction in the simplest form. If you can't see it, it mustn't be there in the scientific method. If it's not observed, it didn't happen. Now, that's not exactly true because trees do still exist in the forest even though you're not there to see them. That doesn't mean they go away when you don't look. Because again, it's perceived reality, and the trees themselves are living, so they have a perception of reality too, just the way we do, just a different perception and a different way of thinking about reality and a different way of existing in that reality. So moving from that forward, we can see that there are planets that may exist in our distant reaches of our own solar system. 8 other ones and 1 dwarf planet, or 9 if you want to contend with Pluto still being a planet. I continually think of it as a planet, so I have to correct myself every time and say dwarf planet. So going from that assumption forward, you're going to say that, well, how do we know that Saturn has rings? Well, we observe them, a structure that looks like rings around Saturn. If you have a good enough telescope, you can see them. At least at a certain time of year, they're visible. Otherwise, you're on the plane that they are, and they kind of disappear, and Saturn looks like just a round ball with no rings. But the Voyager 1 or at least Voyager 2, I think, gave us good, clear depictions of those rings from Saturn. And even Neptune, or not Neptune, but Uranus, and, well, yeah, Neptune too, has rings. And even in some ways, other planets now have rings also. Now, all that means, when you see the presentation of rings around a planet, that doesn't mean that they will always be there. And it doesn't mean that they will always be in that same position or look the same way, because the rings are, in fact, a free-flowing circulation of debris around the planet's equatorial region, where the most of its mass is, magnetized, or at the center of the toroidal sphere that's around the planet that gives it its magnetic field. At the layer of that where it's the middle or the navel of the magnetic field, that's where the rings continually expose or can be seen to rotate around the planet at that certain level each time you look at the planet. Now, if the rings were ever to shift around or indicate polar shift or instability within the core, maybe. Maybe that's the case. But with certain things that happen around Saturn or Jupiter, you can see that maybe the moons at one point may have been large grand rings or larger than any rings in the universe. The same could be said about our moon before it coalesced into the sphere that it is, if it ever occurred that way. We may have had a ring in the past, which was also another theory that was talked about by NASA in the past. And certain channels, and History Channel had shows called The Universe that did talk about that briefly. But I think, moreover, that in light of our recent observations, that we can understand that maybe we're not correct on every single planet, that we don't even know what our own sun's made of, that we think it's a ball of plasma when it may be a liquid, a highly pressurized liquid. Now, magnetism and electronics, electromagnetism, or the electric nature of the star, is what creates its observational era, or the aura, I should say, or the look or appearance of it is created by its electromagnetic discharge. The sun rays that come off of it don't have any heat to them until they interact with our atmosphere, which is why space is so cold, or else it would be the same temperature roughly outside our atmosphere as it is inside it, unless you're part of the contention group or contended group that thinks that, yeah, the atmosphere does create an insulation around our planet, which that is probably true. I've never been to space, so I don't know for sure, for certain, but I can say that theoretical science does point to that being a fact, and you can get evidence of that, at least that space is colder as you go up. That to the surface, where the atmosphere is actually denser, light rays are trapped. They bounce around from surface to cloud, and it creates a heating in our atmosphere, which gives us our surface temperature. Now, the planet itself does also have irradiated heat that comes from the core. That's from interactions with other bodies in our planetary neighborhood. Now, uh, the same thing can be contended with the understanding of electromagnetism. So, with the moon and our own planet Earth, with the moon next to it and the sun way off in the distance, interacting in an orbital fashion, we also are in a motion, constant motion around the sun that gives us our magnetic poles. And the situation of those orbits and the magnetic poles is judged basically on that alignment with the sun's orbit. Now, the nature of that orbit does change over time. We do have several examples of that. One is the precession of the equinox, and the other is the measure of our year. The time it takes us to orbit the sun one time is 365 days based on the length or width of our orbit. So that is also further proof of anything that could be said about magnetism, based on that electromagnetic theory that the planet itself is not just a fireball, that in our core it consists of very magnetic materials that are interacting with the sun itself electromagnetically. That does create its nature. And with humans being mostly water, and we do have elements in us that produce magnetism, minerals and heavy metals, certainly, that make us way more or less based on our density. And the water itself does have within it its own electromagnetic bond. So, with that being said, electromagnetism can force a liquid to bond to a circular or spherical surface. So, with that being said, that kind of sort of brings about the theory of magnetic poles, and brings about the actual presentation of magnetism in the planetary body itself. So that's pretty much it for the universe show today. I'm going to talk a little bit more about it probably in a couple of days or so. Maybe give some different theories, present some more talks about this in the future. But I do want to give credence to someone who helped me learn a lot about this. Nikola Tesla was a very influential mind in helping me understand physics and understand reality a little better. Dr. Richard Feynman also was one of those that I studied quite extensively through the realm of YouTube, and also with other theoretical scientists and physicists that talk about our world as a whole. So I do just want to thank all of them for their contribution to science and their minds, and I hope that we can all learn together. Thank you.